Good evening, everyone. Uh, it's too hot today. Oh, but we are continuing our shenanigans. Why you changed this? Explain yourself. Ba-ba-ba-bum. As usual, where is our repo? Should be here. Okay. So, previously I was looking into file reading. I got here where it's checking for this compression algorithm. We got some dev words here, which is something. So if this is RNC, we will call this function and save the result here. The return apparently is broken because oh my god, what's happening here? I think last time I asked AI about this. Why am I having problems? Internet, are you okay? Excuse me, what? Why you decided to disconnect? Bluetooth? Mm. Will you work today? Just for some reason my headphones decided to die. Hmm. Technical difficulties, sorry. And shows it's connected, but it's actually not. Mm. I hope ceiling will not fall onto me. Okay, they don't wanna work. Let's try and charge them. Oh, okay, so let's try. Where was I? Where is my Ghidra system? So summary. Read 32-bit integer from the address stored in the ESI and return that value unchanged, simply reconstructing it byte by byte. Can you explain a line? Load the string double word. Load the 32-bit value at the address pointed to by ESI into EAX. Then updates ESI increments if the f equals 0, decrement if the f equals 1. In this snippet, the function first fetches 4-byte word from memory, then performs 2-byte swap. And a 16-bit rotate to rearrange low 2 bytes. This sequence effectively extracts a reordered 16-bit values from 32-bit input. So the instruction serves as the data fetch step. That's likely a simple byte swapping or Indian conversion routine. Huh. Exchange. So we are loading into EAX and ALAsh. It's huh. Just EAX. It's 32 bits. ALAsh in some it's 16 bits. So, but this roll does. Interesting. Just this thing is annoying. Yes, Yes, Just interesting. Unaffected. Unaffected. How can I redo it? Maybe. Okay, signature. Let's check. Let's use double word. Here will be basically the same, but so what holds ESI? ESI is open memory. And they're the same. It grabs from ESI and loads it into EIX and compares this thing. Okay. Let me just see this thing in action. Maybe it will be easier to understand like that. Should be like that. Breakpoint. Oh my god. Get back here, please. Disable all. And we need this one. F1, F5, F9, I forgot. Shit. Wrong button. F2. Then why it didn't work? I accidentally pressed F1 apparently. Oops. Okay. So if I will continue, and here we are. We are here. We got this in ESI. And what is this thing? Can I find anything useful? Palette dot apparently the closest I can see, and it's like in many places. So let's see. Theme Hospital. We got data palette dot. Open it here. And that's what we got. Sorry for the flashbang, but dark mode in the HXD is awful. And I don't remember where it is. Okay, so we can see 54, 43, oh, for E4301. That's the start of a file. And there's RNC. Right now, ESI is actually this ESI plus 2. Or not. Compare. Barely. Okay, so basically, it starts with a file itself, skipping the header. If we will go in, so ESI is this address with our file, and we can see A1, 25, 1D, 32. So yeah, 19, 10. So here is the end of this file, 19 by EF. This, I don't know what this end. Okay. Let's see what will happen with this thing. Load as date should populate EIX. So it grabs these 4 bytes. 0, 0, 0, 3, 0, 0, 0, 0. Exchange AL AH. Because they're above 0, we will see nothing interesting. Then roll. Explain the line, please. I'm too lazy to look at the roll explanation myself. Roll rotates 32-bit register left by 16 bits, so half. And rotate preserves all the bits. So we will basically, this 4 will move to this 4. So we'll get 0, 0, 0, 0, 0, 0, 0, 3. So 3 will be here. Yes. Then we again changing this and this. And we will get this. So basically we will get exactly the memory. So basically, yeah, it changes Indians. Don't tell me that all files saved in the different Indians which we need. But the problem is it does this thing only to first 4 bytes. So in EAX we got this thing. Then we are moving this into this. Following dump constant. So this is our thing. Oh my god, what is this? Highest extra use, total extra memory. Interesting. And this is this. So I see it here. SMK graph raw. Interesting. What is this? Isn't this part of a DirectX maybe? Nope. So let's see. So here we store just 4 bytes from a file, and it will be constantly changing. It will be saving different 4 bytes from different files. And it's read only in this function here. Or we will be doing something interesting here. Okay, let's see. Oh my god, not you. Okay, so think we saved this. And because of the Indianness, it will be different. Then we again call the same function. But we got next 4 byte. Because this is 14 now. Yep. And we will get this. We will rotate and get it like here. And we will return and save it here. Add this 4 bytes. Voila, we got it here. 948. This will go here. Next, ESI 5. ESI is now 18, so it's next 4 bytes. We will store it into BL. And it's an address. What the? At 1 byte from this memory. We got 0, 1. ESI plus 5. It's 1D. So yeah, we got this. It's just decoding of RNC. Call this function twice to obtain two 32-bit values. Reads 1 byte from offset 9 of the input block. Yes. But it's not 9. 9 is this, but it reads this. Set up pointers to the first literal after the header, end of the compressed area data. So 93C. That's the size. One 128. Two, yeah, 6. We jumped. Oh, I need 2d8. Така. C, D. Come on, stop jumping. So this. And all of this is the header. Let me read about RNC. Let's see, algorithm. Version. I thought there was a Wikipedia article about this. Rope Northern compression. Okay, this should be this. Form of lossless compression designed by Roland Norton. Thank you. Utilizes Huffman compression. Used by several Bullfrog games. A magic carpet. Oof, I saw a review for this game. It's something. Maybe one day I will play this game just for giggles. Technical specs. Ooh, yeah. Okay. Link to the Corsic, thank you. That's easy. Okay. So here we can see 4 bytes, literal string, RNC 1. Size in bytes of decompressed data. I'm glitching. So it's basically like that. The size of decompressed. Okay. We can go here. So this one, first call, saves here. So RNC size decompressed. This apparently compressed size. Come on. Unsigned integer. Let's data uint. Okay, second one. Size of the bit stream, byte stream, which make up the remainder of the file. We got I got 2db, 2d8. Okay. Oh my god. We got it somewhere. 2d8 here. So this is all header. Yep. 16 size 2. Yeah, there is S2 unknown. Oh my god. But we don't use this. Yep. Check some. We stored what? We stored this. We stored this. And we stored 0, 1 here for now. We got it from here. From here, and it's D, which is 12. Oh no. No, 12 at C, it's 13. Check some of the compressed data. Strange. So signature, size, RNC, size, rest. word. Yes, I. So this, and then immediately this. This is a byte. It's a checksum. No, checksum is this. That's the previous. Oh my god, 4, 8, 12. Strange, they got 12, it's unsigned integer. Checksum. But why it grabs byte, not 2? Then run C, start data, start. Open memory 10. Byte. So we are getting this into 48 here. Okay, 1. Add ESI this plus 6. We got 1E. So this thing. Add EIX12. To EA. So it's a complete length. So basically it's RNC data end. So it's a pointers to the start and the end of a file, of the data in the file. Ooh, but why it's pointing here at 1E? Yes, it's a checksum. Yep. Yep, checksum of a bit stream. Checksum decompressed. Now EBP plus 8. EBP. It's a stack. into EDX. This thing. FOC. FOOC. Okay, it's a start of a file again. Open memory 1. What? EBP plus C, the same. Yep. They all both the same. Yeah, we are calling with the same memory values. CD code. Something like that. Okay, where was I? Here. Add EDX plus EAX. Oh my. So basically EDX will contain the end pointer. EDX to F6. F. Yes, exactly. 003F. So this is the end. This is out. Okay, so, and this was here. And we are comparing stuff. We are getting into this. That's again opposite direction of logic. Okay, so pointer to data and if open memory less than RNC data end, so we are not out of a file, then we're getting pointer to the data end, and we again checking RNC data end with this pointer. Okay. Then jump below or equal. EDX is the end. EBX is start. Oh my god. You charged? Mm. Size. Rest 2 times. To the right. We're dividing it by 4. Why? Wait a second. Ugh. What's happening with my headphones? Mm. Oh. Okay, so EDI. We got start of a file. Okay, pointer. Cleaning EAX. Oh my god, no, cancel. For some reason, my headphones doesn't want to connect to the Bluetooth. Your device is ready to go, and why they're not connecting? Yep. Okay, here they are connected. Strange. Oh my god. Okay. That's a laptop Bluetooth problem. That will be fun if Windows broke something again. Mm. Okay, UDI plus 10. It's that's from here. So one will be this one. 1C, 1C. So we're skipping all of this for some reason. Let's see again. 18 bytes. Seems like it. No. It's 1. So this is a checksum. Or unknown. Let's see. L. Okay. I don't wanna work today for some reason. Oh. So IL, we got 0, basically this one. Then we are grabbing size into EAX. Then what was the point? We adding. Oh my. Is this checking the checksum? Add size. Then EBX, EAX. We got this. Compare wild. EBX, EDX. We are still here? Yeah, it's second check. Oh my god. It's this apparently. Now. ESI and EDX move. Move EBX and EDI. Source destination. Okay, sub ESI 4, sub EDI 4. We're here. Then this again, rest to ECX, and we are doing this now. My god. What the hell? UCX 2 times to the right. So basically by 4. Yep. B6. STD. Don't remember what the hell is this? And repeatedly move double words from source to destination. Тыщ. RNC checksum is 16-bit unsigned integer used to check archive integrity and correct decoding. For the calculating sum. Checksum SOR. Oh my god, the bitstream byte stream. Immediately after the header, the bitstream byte stream begins. The first 2 bits of the bitstream have unknown meaning. The remainder of the bitstream consists of 0 or more compressed chunks. Bit and byte stream is primarily a stream of bits consisting of various sized integer values. Value between 1 and 16 bits. Each value is stored with the less significant bit first and with no regard to traditional byte boundaries. Occasionally a stream of bytes appears in the bit stream, but when it does so, the bytes are delayed, such that they occur after a multiple of 16 bits have appeared in the bit stream. Oh my god. Seems slightly complex, but it has two advantages. Whole bytes can be copied directly from byte stream, as they're aligned to the whole byte boundaries, except for the last byte. It is always safe to read 16 bits at a time from the bit stream. Oh my. STD sets direct flag. Okay. STD to set flag direction. Decrement the source and destination indexes after each element. Move as the rep copies double words for 4 bytes from ESI to EDI. So from here, EDI to here. Repeating this as many times as the value ECX. Yeah, that's why we're dividing by 4, so it grabs by 4 bytes, and so we basically divided byte size into integer size. And you wanna tell me that we will overwrite in place? Source to F2 F2 F So it's somewhere at the end. To F3. No, F3. Okay. F3, it's the next one. So we will put it here after the original file. And after this. So we will see this thing populate. And we are jumping here. A8. Move byte pointer. Where is this thing? 89. 49. That's a byte. I can see something. It's a counter, maybe. And this is 944. 944. Word. KSI. A1C. Interesting. We got it from GSI. Oh. F0. 3, 4. Okay. L2. This function. Oh my god. Mm. 44. RNC data start. But it's not this anymore. It's something from there. Return. Let me see the return. Return like this. Pop AX. Just L here contains 2. we're pushing CX and we're moving IL to CL. Oh my god. And we are setting again some values. Function extracts a variable length field from a packet bit buffer. It first reads a mask of IL bits from one 16-bit word, then shifts and merges the remaining bits into another word, optionally handling wraparound when the requested length exceeds the current segment. Resulting value is returned as an unsigned short. Oh my god. This is 0. Let's see. Get in. L, it's 2. Then we're getting 3 global variables. 46, 49, 44. X, Bx, Ch. And they all 0. This is this thing, and this is this 0. Okay. And the X we got 0. Then this thing 3 times. Oh my. UR6. That's ECX. 1 byte, second byte. Must call. So also some kind of decode via function. And we again calling this function. Again. Nothing interesting. Read a sequence of bytes from the helper function, store them in a temporary buffer, and then interpret those bytes as a series of big packed values into array pointed by param2. So here. This is some kind of buffer. Following dump, this one. So right now it's 0. And if I will call this function, we get something here, but not much. Is this like decoded stuff from the function? $88, $38. It's another place which is 0. If we will call this, we will again get some stuff. RMC temp. But is this like it's a variable length? And it's like written here. And read here. So it's intermediate. We don't really need this because it's never used in the game. And the third place is this we got this. Uh, 38. So this basically also RNC temp, some kind of thing. Then we're getting this again, but we're saving it here. You short. Move AL10 and call this thing. We got 53 and we will store it there. 8942 here. It's also RNC something. Jump. Yep. Oh, move this. $7B8 into EDX. We got address. Come on. Where's the tooltip? So yeah, this one. And we're calling this thing, which again does something. Sequence 16-bit values. Oh my god, for searching for siblings. Looping commands, pointers, stops, matches, global mask. We're exiting the loop, it calls this function to get more 16-bit. There's a counter. File 16-bit is returned. We was here. Wish, jump and move. T9, move to CL again 2. ESI, it's our buffer. I to be X. Roll. And ESI, it's again buffer. Shuffle, masking, decrement, and we are jumping back. And we are again here. AB2, yes. So we're basically reading stream. Okay. Don't connect. The hell. So we will be jumping here until the end of the file. Then decrement, that's here. That's a checksum. We're decrementing for some reason. Checksum. 48. 0. While this not equal 0. 31. And we will jump back. Nope. Okay. And we are getting here. We got out. We got this. And this is basically the size. So we're returning size to here. If size less than 0, print string error decompressing, return -1. If size not equal 0, we will go here. Number of bytes to read will be returned up. Where? 3AB. Okay. Here in the main. But we immediately ignore this. And if this dot not 0, compare this to this. This is 0. It changed only here. It's level. because this is a command line argument responsible for the level. Can I split level? Level arg. The args. Why known data type, sorry. But the args. Just bytes hard coded to 1. Can be written here or can be written here. S. Hospital. Command line args. L level. There was game PQ, I think. Code and cheats. Nope. It's not what I want. Cheatbook the classic games. It's also the same level select okay, but minus S. There was a list somewhere. Does not contain. Corsic, do you have info about this? Configuration. Args. Command line. The same. At least for Corsic. Minus S. What is this? Where is it? Also set this to 1. Wait a minute. S go to here. Okay. Where is my function? Okay, we are here. If it's not 0, we will go here. And we will load a bunch of data. Data M. That. This looks like a switch between resolutions. But okay, let's see if we will go to the next. We will jump here over this call and we will get here. B. O. Let me grab the name. And I forgot the shortcut. Label Alt. Strange. So we are getting into the thing. So if I will go here, we will see this. F. What? There is different. No. FF 38. Following down. Please. Again. Because it's end of this window. The actual address is here. Selected. Okay, data pointer dot. We can get this. Alt. This. That's a pointer to the M pointer. This. Let's see how it's loaded. So we are inside this thing. M pointer open. You also compressed as it's supposed to be. here we're printing string to the log basically. Clean push. Huh? Now come on. We're calling this and just print string. Nothing interesting. La la la, free, read, write. It first clears, then loops to the structure. Just there is actually a structure, not the just string. Oh my god, it finally worked. And it immediately failed. Let's see. Just here I got this thing, but this also contains some data. Oh, no, not this, sorry. This one. This is some kind of structure. What we got right now here? I have no idea. What are they? Okay, so I want to look at this address FF38 here. So this is the name of a file, but here we are actually accessing something inside. Buffer or something like that. Why there's a global? Formats variety argument list into the internal buffer copies into global character array. So not only printing, it's only and also storing it here. Let's see here. If I will just do it like that. Nothing special. Okay, let's inspect this. So we got call to this function 20. Then we're getting ESP plus 148. ESP, it's our stock. We will move to ESI this thing. And we got our address with a string. We will add 4 to ESP. That's the next argument. And move ESI into EBX. Comparing ESI 1C with EDI. ESI 1C, it's a different thing. And this one for OF or FO. Compare. And where is this compare? What are we doing? Jump 0. ESI. Wait, ESI, yeah, ESI plus 1C. 1C. So we got this. And this is what interesting. If I will go here. So this all is one structure, which I have no idea what it is. Create. So data type. So we got this, and this address, which is 1C, is hard coded here. It's a freaking pointer. To here. Okay. So 64. minus 38 to C. Hospital after struct. New. New structure. Is data known as data struct to C. How I understand, 1C is covered by the C string. Terminated C string. 1C. At 1C we got a pointer. And then who knows what. I hope I didn't mess up with the size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7. Ah! 12. Okay. So let's assume and choose here unknown as data struct to C. Data applied will conflict with existing data. Yes. And we basically got this thing. I did data type. Oh, I'm stupid. I already did it. Let me copy this. Apparently, I already discovered some of it. So it's file name, open memory start, open memory end, size, uint. Is byte is allocated in the byte and word. Let's put a struct. Reference use of this. Yeah, okay. I already used it a lot. Whoops. Known status struct. I will remove you. I will just rename this to C. And I can... Oh my god, where is that thing? That's an address. I lost this thing. This one. Oh. Okay. I removed data type. But struct to see. Tish. This one also, I think, should be this. And all of this, I think, also will be the same data. Oh my god. So we got this thing. We need to go here. Oh my. We are in the D2 here. Comparing this, jump no. Section 1. Okay. Clear this. Then EBX, it's our structure. 1C, it's memory start. So this is stored here. I can follow here, and here we will get our file. Also, let me check here. Interesting. Okay, let's see. EAX. This, and we are getting value from here, but that's a 0. We are testing this. If it's not 0, we will clean it. If it's 0, we will just move. Free heap memory, 310. This one. Okay. So we are EBX2C. It's a next file. What? We are skipping. '64 we know. And it's here. So it's an array. Apparently. If we were moving like that. Jump not equal. And we're back. We again EBX plus 1C. It's where is my data? This one C. We're getting this address, which we can follow in the dump too. Here we are. Test jump. Again, jumping to B, and we're getting to C. And we're getting 90 here, but there is nothing. So it's empty. Compare it to 0 and we are out. So it's an array of 2 elements, of 3, but third is 0. So 1, 2, and this is also this, and this is just empty thing. Create array of 3 elements. Overwrite. We got this, and then this accepts not the structure, but the array of structures. To the new. Just I need a new type, which will be basically array of these things. Enum struct. Why I can create array? Array. Test struct to C. To C by 3. To C. I don't remember. To C. E by 3. H4. Okay. 2 to C. Okay. Then I can just remove all of this and duplicate this. And then if I will edit function signature and change this to array of the structures. A little bit wrong. If I will make it array pointers, it will be incorrect. But if I will try create, yeah, it must be a pointer. Because we are passing only 4 bytes, not the whole array. It doesn't understand this. That arrays basically is a freaking pointer array. Okay, that's better. And 0. Just it doesn't understand iteration. Fields. Mm. We're passing an address, which basically a pointer. Which resolves into the array. Okay. I'll let it be like that for now. So we are at 4CO. It's this one. Read file by path. More by name, but okay. And it will return a code. Read file and compress. And this thing should populate all of this. And I got inside uncompressed function. No, it failed to stop. Oh. So we basically did this and a little bit of this. And we failed somewhere. What? Let me see. Let me put it here and let's try again. So we are back here with the same thing. Or not. We got best screen. Let's see what we got here. Following dump. So this, and it seems like the same picture. Yep. Already this part and we can basically look the same here. So this is the part where it's supposed to write. And we got a memory address. This is the pointer. And then if I will go here, I will see big fat nothing. For some reason. Apparently there's nothing to do. Okay, let's move. And we're again here with load Paula. So let's go on dump 5. There is this, there is the address. In dump 1, we got this address. Go dump 2. Memory start path pointer function. Size by memory start. Just at which point we are getting this thing. This one. Let's see again. Let's go in. We got... Oh, there is our M pointer. Dump 5. It's down here. All up here. There is a 0. So go. Move this. Create another key. Oh my god, I will. Let's add a table. Oops. And we got this. Can address. Create heap and allocate. ED1C, it's in this address, okay, and we are moving stuff from this address into the register to test that this is empty. Yeah, it's a size. No, it's a pointer. Yes, this thing. EDI plus 24. Interesting. Then we're calling this function or D5-8. Oh, this one. Return back. Some debug function apparently. It does nothing. Yeah, we basically got why you called like that problem 004. Should be like that. That's why I can't find you. For some reason you named wrong. And yes, move, jump. Then we're calling this. Let's read file and uncompress. So we're getting into else. We're getting size of a file. It's M pointer. M pointer. And the size is 75E. But actual size somewhere here. Size, test jump, add 200, push and call EBX. EBX is heap and create, this one. And from there, we will get the address from a system function. So it will return address where it was able to create this amount of memory. And here we are storing this here. This. Yeah, we got this address, then we should put it inside. And we got this address. For now, it's empty. Then we will uncompress into this, or from this path to this memory. And we passed pointer and the address pointer. And here we should get this. Voila. We got this but uncompressed, so it will not be looking like that at all. Interesting. If is this an actual function? Nope. It's just data. Yeah, so 0. Okay. This is size uncompressed. No, it's unknown. Compressed. Better like that. Yeah, if there is for some reason mismatch of size, something went wrong. We'll nullify all and return minus 101. What the hell? Or everything will go fine and we will get 1. Memory start plus size. So here we will get this. We will have to get this address 3b plus something. Memory start, memory end, memory end. Should be next. So this is start. Why it's empty? No. Strange. If if memory end not equal 0, but ours is equal. Okay, we don't care for some reason for this. And we're getting back into here. Yep, 609. Oh my god. Compare, jump. We will skip most of it. If error minus 100 here, if error minus 101 is here. But if everything okay, we will go there. And there is add ESI2. Compare. Jump back. M pointer tab. Now. Interesting. Add some kind of table or responding stuff. So basically, it may be not an array, but it's one big structure. There is a point tab. We will get 1C this, dump 1. And we got this address. And here we got data. And we again jump, and we will go out of here because we finished. And we will go 439. $4.49 CB. That's 29.02. Almost. Huh? Closest one is this. Maybe. Yeah, because it's not here. Oh my god. Okay, so we got this thing. And then there is a lot of interesting stuff happening. We have a bunch of data addresses. Huh. So here is this thing, yep. 44 DER off. So yeah, it's using this data. Okay, next time I will look how they are connected, because we are using these addresses which came from here apparently. Yeah, 7C. This one I don't know what it points at, but we will see. But that's all for today. I have to go. Thank everyone who survived it. It was painful and slow, but what will you do? I will see you tomorrow with more interesting stream with commandos. See you then. Have a good rest of your day. Have a good rest of your evening, and bye bye.